So in this video, I'm going to demonstrate a technique of partial fractions from section 7.5. I'm going to look at question number 3 in part because it tells you to start out by performing long division, and this is sort of an unconventional rational equation to perform long division on. So I'm going to look, here's my scratch work to set up to be able to perform partial fractions. Notice that the x is in the numerator, and really I could write this as x plus 0. That might make it easier when performing this long division. And I'm dividing that by 9x minus 8. So the first question I ask myself is, just looking at the leading terms, I say, how many times does 9x go into x? And maybe from a whole number perspective, that's not possible. But another way to frame this is 9x times what equals x? And because this operation is over the rational numbers, we know that 9x times a ninth will equal x. And so down in the line below, I'm going to multiply 1/9 by this entire expression, and I get 1/9 times 9x gives me x, and 1/9 times negative 8 gives me negative 8/9. I subtract this expression, and this is where it's helpful to have a 0 here as a placeholder, that there are 0 ones, 0 constant terms. So x minus x is 0, and 0 minus a negative 8/9 is 8/9, which means that this long division yields 1/9 with a remainder of 8/9. And so how do we write this? We'll write this as 1/9 plus maybe 8/9 of 9x minus 8. So something I'm going to do in this video that you don't necessarily have to do, but it's nice to go back and check this. What are we saying here? We are saying this long division yields that 9x minus 8 times what equals x, and we just found that it's times 1/9 plus 8 divided by 9 times 9x minus 8. And we're claiming that this is equal to x, right? So to check this, I'm just going to look at the expression on the left-hand side, and I notice that I have the addition of fractions. I'm going to get a common denominator as my first step, so I leave 9x minus 8 out here, and now I multiply the numerator and the denominator by 9x minus 8, and I get 9 times 9x minus 8 in the denominator, and add that to 8 copies of 9 times 9x minus 8. So now let's add those two fractions. I have 9x minus 8 plus 8 in the numerator, so I'm left with just 9x in the numerator. And the denominator is 9 times 9x minus 8. I see that I can cancel these 9s. And I also see that I can cancel the 9x minus 8s, right? Because this is the same thing as maybe 9x minus 8 over 1 times x over 9x minus 8. And I end up with a value of x, which is what we want. Maybe I should write that in red. Nice. Cool. So that was sort of the tricky part in this problem, was setting up the long division. It means that I can rewrite this integral. This is equivalent to the integral of 1/9 plus 8 divided by 9 times 9x minus 8 dx. And I can break this up into two separate integrals. This is my messy work. So this is the integral of 1/9 dx plus the integral, I'm going to pull 8/9 out front, of 1 over 9x minus 8 dx. And individually, each of these integrals are pretty easy to compute. That this first integral I can use power rule. This is 1/9 x, right, because I'm adding a power of x. And the second one, I'm actually going to do a u substitution. I'll let u equal 9x minus 8. So that way du is equal to 9 dx. So to compute this integral, I don't have a 9 in here, so I'm going to multiply the interior of the integral by 9, and I'm going to multiply the exterior by 1/9. Let's recopy this so I have a little more space. 1/9 x plus 1/9 times 8/9 times the integral. The 9 dx becomes a du, so I just get 1 over u du, and I can use the fact that the integral of 1 over u is the natural log. 1/9 x plus 8 over 81 times the natural log of u, but u in this case was equal to 9x minus 8 plus c. So the other thing that I want to talk about is actually what WebAssign is asking on 7.6 number 1. We are given a function and we're asked to evaluate the integral from 1 to r of this function, and it's sort of confusing. What do they want in this box? What they want should have a capital R somewhere in here, so I'm going to write part A down here. Part A is taking the integral from 1 to r of f of x. F of x in this case is x to the negative 8/5 dx. So to evaluate this integral, I can use power rule, that I add 1 to the numerator, so that becomes negative 3/5, because I'm adding 5/5 to the numerator, and then that'll be multiplied by negative 5/3, and we evaluate this from x equals 1 to x equals r. So this ends up being negative 5/3 of r to the negative 3/5. So evaluated the upper bound, and then I subtract out evaluating at the lower bound, negative 5/3 of 1 to the negative 3/5. But 1 raised to any power over and over again is itself. So we end up with, this is just 1, this is a positive 5/3 minus 5/3 r to the negative 3/5. Now for part B, we can evaluate the limit. So this is the part that goes up into here. For part B, we're going to take the limit of this integral as r goes to infinity. So I'm going to take the limit as r goes to infinity of 5/3 minus 5/3 r to the negative 3/5. And recall, anything raised to a negative power is the same thing as being raised to the positive power, just in the denominator. So this is 5/3 times 1 over r to the 3/5. And as r approaches infinity, this value approaches a very large number, which means the limit of this is equal to 0. So this term becomes 0, and I end up with a limit that is 5/3. And that's what's being asked for in part B.